Recording starts. And I've also noticed that my cell phone says 11:19 and my computer says 11:25. And usually your phone is synced with the computer, I thought. And well, not synced, but they have the same time. And I don't know 19 or 11:24. Or have I traveled forward in time?
Oh yeah, my computer and my phone.
11:19.
Yeah. What it is I've traveled back in time 4 minutes, 6 minutes. So maybe I'll catch up to the real time eventually. Okay, just a reminder, I went over all that stuff with y'all the other day about the last day of class. I did go in and check the probability of statistics test just a few minutes ago, and it has 33 questions with 13 or 14 bonus questions on it. So you're talking about around 20 questions, something like that. So that's on there, and it's coming from chapter 12 and 11, and we're going to finish 11 today. I will go over questions here in just a minute. I got one question to go over. I'll go over questions and tests. I'll probably go over that test Friday, and then questions on any homework. I'm going to cover probability homework today, which is the one question that I'm going to go over. And then Friday and Monday will be open to all homework questions and tests. But I want to get the test done first, so that way you can go ahead and work on the test. I have one question from 11.1, and that is 11.185/15. First of all, is it a homework question? Yes. Or a test question? Yes. And this is a standardized test question also. So you might want to write this one down because you might see it again on a standardized test. Pull up my handy dandy. Okay, a beanbag is randomly thrown into a square table, and does not touch a line. Determine the probability that the beanbag lands on an area that is green or red. What does or mean? Oh, 1 minute. 11.1 or, okay, I thought I was in 120 there for a minute. All right, let's go ahead, and we're going to have to add these two. Yeah. You throw a bag, you hit it right here. I'm going to divide this into, you have to divide everything into parts. Okay, so let's go ahead and take my handy dandy. There's how many different colors? There's 3 colors. It looks like there's 3 colors. There's red, there's yellow, and green. Okay, now you can actually divide each one of these up, and I'm going to draw this out so you can see it. And red, yellow, green, red, green, yellow, green, red, green, red, and yellow. Now, in order to do this problem, you've got to think of this as one of two, or you got two parts to this square, two parts to this square, one part here, two parts and three parts. So you got to organize your data accordingly. And how do you do that? Well, how many big squares do you have? Well, you've got 6 big squares. Well, green is going to be 1 out of those 6. Okay, so that takes care of this one. Yellow is 1 out of 6. That takes care of this one. All right, so those 2 middle ones are taken care of. Let's talk about these down here. Okay, and how many boxes do we have? Well, there's 4 boxes. Okay, or you could say, you know, two out of 2 rectangles right here that make up this square box, and 2 rectangles here that makes up this box. You could do it that way, but I'm going to do it as 4. Okay, so red is 1/4. Yellow is 1/4. Green is 1/4. And red is 1/4. So that takes care of those. And then the last one, well, I've got one box divided in 2 halves. Yellow is 1/2. And red is 1/2. So that takes care of those 2. And then these got one box. I mean, there's 3 boxes here. So green is 1/3. Red is 1/3. And green is 1/3. So how many boxes do we have at all? Well, let's count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So we're good. Now, if you want to get a common denominator, you could do that, and we could do that, no problem. The common denominator of 2, 3, 4, and 6, 2, 3, 4, and 6, 2, 3, 5, 7, 11, and sometimes 13. 2, that'll be a 1, a 3, a 2, and a 3. 3 be 1, 1, 2, 1, 2 will be 1, 1, 1, 1. So what's 6 times 2? 12. The common denominator is 12. So we can change all of these to 12ths, and we could, you know, have no problem doing that. So I'm going to change all of them to 12ths. So how's the best way I could do that? I guess go down here and do red. That's going to be a 12, a 12, a 12, and a 12. Now you don't have to do this, okay? I'm just doing it to show you how's the easiest way to understand it. Yellow, 12, 12, 12, and green, 12, 12, 12, 12. All right, 4 will go into 12. 3 times 1 is 3, and that would be a 3 there also. 2 will go into 12. 6 times 1 is 6. And 3 will go into 12. 4 times 1 is 4. 6 and 4 is 10. 16 over 12. Okay. 6 will go into 12. 2 times 1 is 2. So that would be a 2. Oh, I'm sorry. 4 will go into 12. 3 times 1 is 3. And 2 will go into 12. 6 times 1 is 6. And that'd be 6 plus 3 is 9, 10, 11. That would be 11 over 12. And then this one, 6 go into 12 twice, that'd be 2. 4 will go into 12 3 times, that'd be 3. 3 will go into 12 4 times, that'll be a 4, and that'll be a 4. And that will be 2, 3, it's 8, 9, 10, that'd be 13 over 12. Now, it's asking, what is the probability of green or red? Now, when you do green or red, you're picking one time, and it's what's the probability of you picking a green or a red? So you're going to add them together. So green is 13/12, and red is 16/12. And I feel like I'm doing something wrong on this problem. But that is 16/12 plus 13/12. And I know I'm doing something wrong because you shouldn't get a probability of above 1. So I know I've done something wrong here. That's 29/12, and that's not right. So let me look at it from a common sense standpoint. The problem I got is with these two right here. If you got a common denominator and added all those up, you should get, yeah. Let me see what they did, because yeah, they're adding. I thought they would add, that's right. Oh, they're using the complement. There's the 12. Okay, so far it looks like they're doing what we're doing. I don't believe they got 18. 2, 3, 4, and 6. Let me make sure I got the right denominator. 2 will go into 2. 2 will go into 6. 3, 1 will go into 3 one time. 2, 1. Looks like I've got the common denominator, but they're coming up with 18 as a common denominator. Yeah, they're coming up with something different. So I'm doing it right. I've got something different than they've got. I should have the same answer. Okay, we've got 2, 3, 2, 3, 4, 2, 3, 6, and 4. Okay, I'm coming up with 12, and they're coming up with 16. So I'm confused. I'm really confused. This problem is not that hard. Why am I making it hard? There's something I'm missing. Okay, I've done this problem before. I did it last semester. Why am I having a problem? Okay. Y'all can interject anytime y'all want to.
I couldn't figure out where they got the 18 either.
Okay, so I'm not the only one.
That's why I sent it.
My numbers I'm not supposed to have 16 over 12. See, that's the problem I've got. I'm missing something. Let me go back and see. Wait a minute. 1, 2, 3. There's where they're getting 18. Oh, I know what I'm done wrong. I know what I've done wrong. Okay, this 3 right here is where I went wrong. This 3 right here. Okay, let me start over because I've done something totally wrong. Okay, let me draw it again, and this time I'm gonna draw it correctly because I drew something. I forgot something. And across, and down. And this one goes there, and this one goes here. And this one is 1, 2, and this one is half, and this one is half. Okay, and that's red, yellow, green, red, green, yellow, red, yellow, green, red, green. Okay, I just messed up on one. I messed up on this one. Okay, let's start with these two. How many of these big boxes are in this whole thing? There's 6. So green, yellow, and red. All right, 1 out of 6, and 1 out of 6. Okay, so green's taken care of. That one and that one's taken care of. Now, the next one, let's go with these. How many are in the whole thing? There's 12. 1, 2, 3, 4 times 3. 1, 2, 3 is 12. So these are going to be 12s. Okay, so 1 out of 12 is red. 1 out of 12 is yellow. Green is 1 out of 12. Okay, what did I just do? Red, yellow, green, and red is 1 out of 12. So we just did these. How many of these diagonals are in this whole group? 12, because there's 2 in each. 2, 4, 6, 8, 10, 12. So diagonals, that'll be yellow is 1 out of 12. And red is 1 out of 12. And here's where they get to 18. There's 3 in this group. So how many are in the whole? If you was to break each one of these up into 3 spaces, 3 times 6 is 18. So green is 1 over 18. Red is 1 over 18. And green is 1 over 18. And that's where you get your numbers. I messed up this one because I said 3. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Now we should come up with the right answer. So I knew I'd done something that I couldn't see. And that's when I saw the 3, the 18, that's when I said, now let's change everything to a common denominator. 6, 12, and 18. 2, 3, 5, 7, 11, and sometimes 13. And my black pen is dead. Hold on. So 2, give me a 3, a 6, and a 9. 3, will give me a 1, a 2, and a 3. 2 will give me a 1, and a 3. And 3 will give me a 1, 1, and a 1. And now we've got 36. That's not right. Well, I'm going to do it as 36, and hopefully that'll work. Hopefully this will work. I don't know. Green, yellow. The example might be 18. This one might be 36. And red. And 36, 36, 36, and 36. Six will go into 36. 6 times 1 is 6. 12 will go into 36. 2 times 1 is 2. 18 will go into 36, 2. And 18 will go in there, 2. That looks better. 6 plus 2. 6 plus 6 is 12 over 36. That looks a whole lot better. Yellow. 36, 36, 36. We can check it to make sure because all the numerators added up should equal 36 when we get through. Or 18, depending on what your common denominator is. 6 go into 36. 6 times 1 is 6. 12 will go into 36. 3 times 1 is 3. And 3. And that'll give us 6. And 6 is 12. So that's 12 over 36. And then red, 36, 36, 36, 36. 12 will go into 36. 2 times 1 is 2. 2, 2. 18 will go into 36. 2 times 1 is 2. So that's 2, 4, 6, 8. That's 8 over 36. And 24 and 8 does not give you 36. It gives you 32. So I'm missing something. Shoot. Let me check everything. 6 will go into 6. 12 will go into 36 3 times. Oh, this is it. 3. 12 will go into 36 3 times. 18 will go into 36 2 times. 18 will go into 36 2 times. Make sure so that should be 13. 6 and 4, yeah, that'll be 13. So that'll be 13, that's 20, let's see, 8, 12, and 8, that'd be 33 over 36. 6 will go into 36 6 times. 12 will go into 36 3 times. 12 will go into 36 3 times. 12 will go into 36 3 times. There, I did it again. That's a 3, that's a 3, and that's a 3. There we go. And that's 9, 10, 11. So 11 and 24 or 25. There we go. Now we cooking with peanut oil. Okay, so besides my mathematical mistakes, there's the probability of green is 13 over 36. The probability of yellow is 12 over 36. And the probability of red is 11 over 36. And they want to know green or red, I think. And you're going to add those two together. That should be the answer. So green is 13 over 36 plus 11 over 36. And that's equal to 24 over 36. And they want it, I don't know if they want a fraction or a decimal, so I'm going to turn it into both. So let me get my handy dandy calculator. And I'm going to do second quit. 24 divided by 36.67 equals 0.67. So that should be your answer. And I apologize for the confusion, but first I had a brain bubble, and second I had a mathematical mistake. So 0.66, I guess 67. Let's see what they get. Okay, 2/3 is 0.67. Thank you very much. So, Mr. Searcy, does that help, even though I bungled up one of them and had a mathematical problem? Is that okay?
Yes, that's fine. Thank you.
Do you understand where they get the 36? In this, in the previous one, in the help me solve this, it was 18. In this one, it was 36. You want to do it again?
No, I got it. I think I got
Okay,
it.
got it?
Yeah.
Okay. Now let's go to odds. Now, as I talked to you the other day, I told you the odds against, and that's the only one we really care about, because that's what the gamblers want. Odds against is equal to the probability of failure over the probability of success. And I told you, let me get my red marker. I told you to make sure you try to keep, and that's not red. I've lost my red mark. No, I've ran out of red markers. Here we go. Nope, that's not red. I know, it's when it comes to me and my markers, just leave me alone. Okay. And I told you that when you're doing these problems, leave everything as a fraction because it'll make the math easy. Okay. Also, the reciprocal of odds against is odds in favor. The reciprocal of odds against is odds in favor. So if you wanted to find the odds in favor, you just flip this. Okay, so I'm going to write odds in favor is equal to the probability of success over the probability of failure. Now, you might be asked the odds in favor on a test or a homework question, but 90% of the time, a gambling question, they're going to ask for odds against. Okay, so that's what I'm going to harp on. I'm going to harp on the odds against. So let's say I want to put money on a deck of cards, and I bet Miss Hatton that I'll bet $50. I can't write. That I pick a red card. Everybody with me? I say I shuffle up the deck of cards and I fan them out, and I tell Miss Hatton to shuffle them and fan them out and cut them, and I pick a card. And if I pick a red card, she's got to give me $50. That ain't the way it goes. Okay? The way it goes is I pick the card, and if I win, this is how much I get because of the odds against. So the probability of winning in this question right here, because this is a question, probability of winning or the probability of success. How many red cards are there in a deck of cards? That's not rhetorical. I'm asking y'all for input. What's that for 52?
26.
Thank you. I appreciate the interaction.
You're welcome.
Miss Cersei, you're going to have a nice office. The rest of these people, they're going to be in a closet office, and nobody's going to talk to them because they're introverts. All right. So probability of success is 24 over 24. I'm sorry, 52. Therefore, the probability of failure is equal to 24. I'm sorry, 26. I don't know where I'm getting 24 from. 26 over 52. So we get the probability of failure is 26 over 52 divided by 26 over 52 multiplied by 52 over 26. And I get a 1-to-1 ratio, 26 over 26, which is equal to 1-to-1. So I'm not going to win anything. Why? Because I've got a 50-50 shot at getting a red card. But let's change it. Okay? Let's change it and say I want to pick a face card. And I bet $50 that I pick a face card. Well, a face card is the probability of success of a face card is equal to 12 over 52. Therefore, the probability of not pulling a face card is equal to 40 over 52. So now I'm going to do my odds against picking a face card. Odds against picking a face card is equal to 40 over 52 divided by 12 over 52 multiplied by 52 over 12. 52's cancel, and now my odds against a face card is 40 to 12 or 40 to 12 or 40 to 12. Now you can reduce that 6 and then be 10 to 3 or 10 to 3. Well, what does that mean? Well, that means that 10/3 is going to be multiplied by $50. And what is that? Well, let's take our handy dandy calculator. 50 times, parentheses, 10 divided by 3. And I win $166.67. So I've won basically 3 times my money. Why? Because the odds against. Let me give you a little generalization about the odds against. What happened between the red card, which I didn't win anything because I had a 1-to-1 odds against, and a king? What happened? Explain to me what happened to make the 50 jump up to 167. What happened? And yes, I want you to talk. Come out of the closet. Come on. Come out of the closet office and speak with the rest of the world. Oh, my Lord. This generation wants to start a revolution. They can't even put a sentence together. Anyway, what happened? The probability of winning went up or down? Here's the probability of winning, 26 over 52, which is 0.5. What happened to the probability here? Well, what's 12 over 52? 12 divided by 52. 0.2.
The probability of winning went down.
Thank you, Mr. Bustos. Did that hurt? I mean, did that physically hurt you to talk?
No, I'm just following along and taking notes.
That's all right. I'm just picking at you. I'm glad you're following along. Most people will be watching cartoons right now. Miss Hatton. Miss Hatton's watching cartoons. Anyway, so what can we generalize? See, she didn't even respond. We can generalize that if the probability of winning is low, the odds against will be what? Well, let's see what happens. Here's when the probability is high. What was the odds against was what? Low. I'm sorry. When the probability is low, I'm sorry. When the probability is high, the odds are what? Low. Okay, so when the probability of winning is low, the odds will be what? High. Thus, we have Las Vegas. Corona. Let me give you another example. There's a roulette table at the casino, and this is a standardized test question and my test. So I'm going to pull up a roulette table. Let's pick this one. Well, I want one. Usually they have a 0 and a double 0. I can't see one. Well, let me see. 0 and double 0. There's one. Okay, so I'm going to pull this thing in. Let's see, I guess I'll have to do it. I'll just do it on a Word document. Things I do for y'all. Y'all should be so thankful. Insert pictures. All right, so there's the roulette table. Now I want everybody to look at that roulette table, and I want you to see what is the highest number on that roulette table. I'm looking at 36 so far. See if somebody gets higher than a 36 for me. Anybody see a number higher than 36?
Nope.
No.
All right, so we got a roulette table. And I'm going to move this over to the side. Well, I don't know if I am or not. And pull up my handy dandy do-jigger. I got a roulette table with 36 slots labeled 1 through 36 and 0 and 00. Does everybody agree with that statement? Does everybody agree that I have a 0 and 00 on this roulette table?
Yes.
Okay. So I want to know the probability. What will happen if I put my money, I put $50 on red. Okay, do y'all know how the roulette table works? Somebody say yes or no.
Yes.
Okay, then that means everybody else does because they're not talking to me. So you spin the roulette table clockwise, and then you put the marble on the rail counterclockwise, or vice versa. And then you let gravity take control, and it slows down friction, and gravity slows down the roulette wheel, and then gravity takes over and friction takes over the marble, and not Marlboro, not a cigarette, marble. It falls off the rail and falls into a slot, and it'll either fall in the black or the red or the numbers or zeros or whatever. And you place your bet on the roulette table based on what you want to bet on. So the safe bet is red or black. Why? Because the probability of red is equal to, well, how many slots are on the table? Well, there's 38 total on the table. Somebody tell me what the 38 represents. 36 plus 2. How many are red?
18.
18. Therefore, what's the probability of not red? I'll take my handy dandy red marker and I mark through that red. Well, that'd be 30. I'm sorry, 20 over 38. Now, I want everybody to look at those two fractions and make sure you understand them. You can also do this with even and odd. Even would be 18 over 38. And not even would be 20 over 38 because 0 and 00 are neither odd nor even. And it says that in the homework or test question when it asks for even or odd. So if you're asked even or odd, it's going to be the same setup here. Now let's do the odds against. Probability of failure over the probability of success. Multiply by 38 over 18. 20 to 18. Simplify. Well, 2 will go in there. 10 to 9 or 10 over 9 times $50. Let's take our handy dandy calculator. 10 divided by 9 times $50. Woohoo! We won $5.56. And what do you say about that? You're in Vegas and you just went to the roulette table and you won $5.56. Now, what do you say to that? Do you jump around and do cartwheels?
Not
or do you
worth the
say,
bet.
that sucks?
That sucks.
Exactly. Why? Well, look at your probability. We're going to take a green marker here. Somebody take 18 and divide by 38, please. Tell me what you get. I'll do it. 18 divided by 38. The probability of winning at the roulette table, if you pick even, odd, black or white, black or red, is point what? 0.47. In Vegas odds, is that high or low? Anything above 0.1 is high for Vegas. So you've got a high probability of winning. You've got a high probability of winning. So if you've got a high probability of winning, Vegas ain't in the generosity business, okay? They're not in the philanthropy business. Vegas is there to take your money, all right? If they got a probability on a game that's very high, the payoff is going to be very what?
Low.
Low. Because Vegas is not in the giving away money business. Now, let's change it. Let's say that you bet $50 on green. Let's say you say, well, that sucks. $5.56 sucks. So I'm going to go and I'm going to bet $50 on green. All right, I want you to do that one. I'll even give you a start off. The probability of green is 2 out of what?
38.
Okay, take off. I want you to do the whole problem. I want you to find the odds against. I want you to multiply that by $50 and see what you get, and then we'll do it together. And just so everybody knows,
you have a work email.
2 divided by 38 is 0.05. So you've got a probability of 0.05. I'm going to just put that out here to the right. You don't need it, but 0.05. You got a 5% chance at winning with hitting a green. So the payout's going to be big. So somebody tell me what the probability of not green is.
$36 over $38.
Good job. And the odds against is equal to the probability of failure over the probability of success. Multiply by the reciprocal. You get 36 over 2, which is 18 to 1. Multiply 18 to 1 times 50. 18 times 50. And you win $900. Now what do you say about Vegas? That's great. Why? Because you won some money. How did you win money? You played the odds. You went to a table, and instead of playing penny ante stuff with a probability of winning equal to 0.47, you decided to play a little bit riskier with the probability of winning being what? 0.05. So when the probability of winning is low, the payoff is high. When the probability of winning is high, the payoff is low. Nothing in this world is what?
Free.
Free. Okay? You're not going to go in to Vegas and go, okay, well, I'll just play red or black. And you may get enough money to tip the bellboy to take your luggage to the room. Okay? That's about all you're going to get. All right? There's an old saying in business, in order to make money, you have to what?
Spend money.
Thank you, Miss Cersei. You get tired of answering questions by yourself all the time?
Sometimes.
Yeah. It would
Sometimes
help
I
if the
just
rest
don't
of the
answer
class
because I don't know.
Huh?
Sometimes I just don't answer because I don't know the answer.
Exactly.
Oh,
I agree.
this hat just woke up.
No, I've been here. Something wrong with my mic.
Oh, yeah. Now she's having technical difficulties. All right. So let's go with, and Mr. Brickman, he just quit on me. First of the semester, he talked to me every day. Now he just says, bump him. I don't want to talk to him.
He's part of the Russians.
Yeah, that's it. If the
I actually
probability
say
of
that
winning, what?
I actually had a teacher say that one time. We were in one of my history teachers. He was like, I forgot why. He was talking about like students giving people answers, and I was like, "That's horrible." And he's like, "One of the Russians." Hey, he was like, he thought I was suspicious for saying it was bad.
What class was that?
It was I think it was U.S. history.
It wasn't the Chad Gregory, was it?
No, I
Oh,
had.
God, I love Chad Gregory. He's so funny. He's got a real dry personality, a real dry sense of humor.
I love
And
those kind of people.
you have to really listen to pick up on when he is being funny and sarcastic. Anyway, probability of winning is high. The payoff sucks. $5.56. When the probability of winning or success is low, the payoff is high. $900 versus $5.56. And that, my friends, is odds. So remember, the odds against is equal to the probability of failure over the probability of success. And then whatever that number is, when you get that fraction, you multiply it by the bet. Now, sometimes they're just going to ask you for odds against. And sometimes they're going to say, what if you place a $100 bet? Then that's when you multiply it by this number, whatever this number is. And you always simplify, always use fractions and always simplify. Odds in favor, which is hardly ever asked, except on a test maybe, is the probability of success over the probability of failure. And it's just the reciprocal. So if you get a 2/3, then this will be 3/2. Okay? And I don't usually ask this. I usually ask the odds against. Okay. All righty then. Okay, we have just concluded. Hold on. We have just concluded the semester. Okay. We have 2 days to finish whatever you want to finish. And some of y'all have already sent in questions on the chapter 7 and chapter 8. And some will send questions on 12 and 11. We will try. I want to cover the test first Friday. Okay. And I'll cover the test on probability and statistics. I'll do that first Friday. And then we'll leave the rest of Friday and Monday for questions on anything that you have. Okay? Who's got questions on anything so far? Okay. Well, I will see y'all Friday, and I hope y'all have a good day.
You too.
See ya.
All right.